The electronic color code is used to indicate the values or ratings of electronic components, usually for resistors, but also for capacitors, inductors, and others. A separate code, the 25-pair color code, is used to identify wires in some telecommunications cables. The electronic color code was developed in the early 1920s by the Radio Manufacturers Association, and was published as EIARS 279. The current international standard is IEC 60062, published by International Electrotechnical Commission. Color bands were used because they were easily and cheaply printed on tiny components. However, there were drawbacks, especially for color-blind people. Overheating of a component or dirt accumulation may make it impossible to distinguish brown from red or orange. Advances in printing technology have now made printed numbers practical on small components. Where passive components come in surface mount packages, their values are identified with printed alphanumeric codes instead of a color code. Resistor color coding. To distinguish left from right, there is a gap between the C and D bands. Band A is the first significant figure of component value. Band B is the second significant figure. Band C is the decimal multiplier. Band D, if present, indicates tolerance of value in percent. For example, a resistor with bands of yellow, violet, red, and gold has first digit 4, second digit 7, followed by 2 zeros. 4700 ohms. Gold signifies that the tolerance is plus or minus 5%, so the real resistance could lie anywhere between 4465 and 4935 ohms. Resistors manufactured for military use may also include a fifth band which indicates component failure rate. Refer to MIL HDBK 199 for further details. Tight tolerance resistors may have 3 bands for significant figures rather than 2, or an additional band indicating temperature coefficient. In units of ppm, K, all coded components have at least 2 value bands and a multiplier. Other bands are optional. The standard color code per N 60062 to 2005 is as follows. Resistors use preferred numbers for their specific values, which are determined by their tolerance. These values repeat for every decade of magnitude, 6.8, 68, 680, and so forth. In the E24 series the values are related by the 24th root of 10, while E12 series are related by the 12th root of 10, and D6 series by the 6th root of 10. The tolerance of device values is arranged so that every value corresponds to a preferred number, within the required tolerance. 0-ohm resistors are made as lengths of wire wrapped in a resistor-shaped body which can be substituted for another resistor value in automatic insertion equipment. They are marked with a single black band. The body end dot or body tip spot system was used for radial lead composition resistors, sometimes still found in very old equipment. The first band was given by the body color, the second band by the color of the end of the resistor, and the multiplier by a dot or band around the middle of the resistor. The other end of the resistor was colored gold or silver to give the tolerance, otherwise it was 20%. Capacitor color coding. Capacitors may be marked with 4 or more colored bands or dots. The colors encode the first and second most significant digits of the value, and the third color the decimal multiplier in picovarads. Additional bands have meanings which may vary from one type to another. Low-tolerance capacitors may begin with the first 3 digits of the value. It is usually, but not always, possible to work out what scheme is used by the particular colors used. Cylindrical capacitors marked with bands may look like resistors. Asterisk or plus or minus 0.5 picofarads, whichever is greater. Extra bands on ceramic capacitors identify the voltage rating class and temperature coefficient characteristics. A broad black band was applied to some tubular paper capacitors to indicate the end that had the outer electrode. This allowed this end to be connected to chassis ground to provide some shielding against hum and noise pickup. Polyester film in gumdrop. Tantalum electrolytic capacitors are also color-coded to give the value, working voltage and tolerance. Diode part number. The part number for diodes was sometimes also encoded as colored rings around the diode, using the same numerals as for other parts. The JEDEC1N prefix was assumed, and the balance of the part number was given by 3 or 4 rings. Postage stamp capacitors and war standard coding. Capacitors of the rectangular, postage stamp form made for military use during World War II used American War Standard or Joint Army-Navy coding. In 6 dots stamped on the capacitor. An arrow on the top row of dots pointed to the right, indicating the reading order. From left to right the top dots were either black, indicating Yan mica, or silver, indicating AWS paper, first significant digit, and second significant digit. The bottom 3 dots indicated temperature characteristic, tolerance, and decimal multiplier. The characteristic was black for plus or minus 1000 ppm, degree C, brown for plus or minus 500, red for plus or minus 200, orange for plus or minus 100, yellow for minus 20 to plus 100 ppm, degree C, and green for 0 to plus 70 ppm, degree C. A similar 6-dot code by EIA had the top row as first, second and third significant digits and the bottom row as voltage rating, tolerance, and multiplier. A 3-dot EIA code was used for 500-volt 20% tolerance capacitors, and the dots signified first and second significant digits and the multiplier. Such capacitors were common in vacuum tube equipment and in surplus for a generation after the war but are unavailable now. Mnemonics. A useful mnemonic matches the first letter of the color code, by order of increasing magnitude. Here is one that includes tolerance codes gold, silver, and none. Bad beer rots our young guts but vodka goes well, get some now. The colors are sorted in the order of the visible light spectrum: red, orange, yellow, green, blue, violet. Black has no energy, brown has a little more, white has everything and gray is like white but less intense. Examples. From top to bottom. Green, blue, black, black, brown 560 ohms plus or minus 1%. Red, red, orange, gold 22,000 ohms plus or minus 5%. Yellow, violet, brown, gold 470 ohms plus or minus 5%. Blue, gray, black, gold 68 ohms plus or minus 5%. The physical size of a resistor is indicative of the power it can dissipate, not of its resistance. Transformer wiring color codes. Power transformers used in North American vacuum tube equipment were often color-coded to identify the leads. Black was the primary connection, red secondary for the B+, red with a yellow tracer was the center tap for the B+ full-wave rectifier winding. Green or brown was the heater voltage for all tubes. Yellow was the filament voltage for the rectifier tube. 2 wires of each color were provided for each circuit, and phasing was not identified by the color code. Audio transformers for vacuum tube equipment were coded blue for the finishing lead of the primary, red for the B+ lead of the primary, brown for a primary center tap, green for the finishing lead of the secondary, black for grid lead of the secondary, and yellow for a tapped secondary. Each lead had a different color since relative polarity or phase was more important for these transformers. Intermediate frequency tuned transformers were coded blue and red for the primary and green and black for the secondary. Other wiring codes. Wires may be color-coded to identify their function, voltage class, polarity, phase or to identify the circuit in which they are used. The insulation of the wire may be solidly colored, or where more combinations are needed, 1 or 2 tracer stripes may be added. Some wiring color codes are set by national regulations, but often a color code is specific to a manufacturer or industry. Building wiring under the U.S. National Electrical Code and the Canadian Electrical Code is identified by colors to show energized and neutral. Conductors. grounding conductors and to identify phases. Other color codes are used in the UK and other areas to identify building wiring or flexible cable wiring. Thermocouple wires and extension cables are identified by color code for the type of thermocouple. Interchanging thermocouples with unsuitable extension wires destroys the accuracy of the measurement. Automotive wiring is color-coded, but standards vary by manufacturer. Differing SAE and DIN standards exist. Modern personal computer peripheral cables and connectors are color-coded to simplify connection of speakers, microphones, mice, keyboards and other peripherals, usually according to the PC99 scheme. A common convention for wiring systems in industrial buildings is black jacket AC less than 1000 volts, blue jacket DC or communications, orange jacket medium voltage 2300 or 4160 V, red jacket 13800 volts or higher. Red jacketed cable is also used for fire alarm wiring, but has a much different appearance, since it operates at relatively low voltages. Local area network cables may also have jacket colors identifying, for example, process control network versus office automation networks, or to identify redundant network connections, but these codes vary by organization and facility.